Okay, hey everyone, thank you so much for coming. I have a little about me section built into the slideshow, so I'm just going to get started. This is my exit presentation for the summer of 2018. I'm going to be talking primarily about analyzing communication in pursuit of improved human autonomous system teaming. Let me step out of the light here. So I'm going to start with a little about me and then introduce you to the HINGE project. Many of you are familiar with it, so I'll try to go through that pretty quickly, and then talk about some of what I did on the HINGE project. So we'll talk about some of the methods of analysis I used and some of the results we're getting, and importantly, some of the future work that is yet to come, as well as some of the other NASA work I did here that was not so associated with HINGE, but still pretty interesting. So a little bit about me. My name is Meszaros. This is my third semester, third time back at the Autonomy Incubator. These are some of my adventures from this summer. It's a great and fun place to work. Yeah. Notice the beards on the whiteboard on the bottom. In September, in just a couple of weeks here, I'll be starting a PhD at Brown University in Egyptology and Historiology, focused on the history of science and antiquity. So I'm approaching this from a little bit different standpoint than maybe some of the other presentations that you've seen, a little more social sciences informed, a little more humanities informed. So let me introduce you to the project that I spent most of my time working on. I joined the HMI, the Human-Machine Interaction team, working on the HINGE project, which is the Human-Informed Natural Language GANs Evaluation, which is basically trying to answer the question, how can we gather image description information from human users? How can we do this as best as possible? And how can we use that information to help train a GAN or to help get good results from a GAN? So what is a GAN? This slide is filled with way too many acronyms, I apologize. GAN is a generative adversarial network. Basically, it takes in human language descriptive data and produces a picture, produces an image from text. In order to make a good image, we need to give it good text. And so the HINGE project focused on how we can get good training data in order to build up the machine learning algorithms necessary to do this, and also how we can use the GAN later to best produce an image from the description that a human gives it. This is all part of the Attractor project, which hopefully you're all familiar with now. If we can determine what makes a good description, if we can explain that, then we can communicate that to the user and provide and elicit better information from that user. It's all about improving transparency and accuracy with the human-machine interaction, which will hopefully then increase trust, or at least start to work to establish a basis for trust between the human and the machine, and hopefully lead to improved mission success as well. So with that being said, HINGE performed an experiment. I was not here for this, so I apologize for presenting out on this. This is the work of Lisa, who is not here, Brian, Mary Carolyn, who's left. So the team is a little bit dwindling. But basically, they chose 5 images from a data set of images that all included a human in some fashion, doing some sort of action. Those images all came from the Pascal 50S data set, which I'm going to talk about later, but you don't need to know much about it now. We then took those 5 images and asked users to provide descriptions for those images using 2 different methods, either by speaking and us recording their speaking, or by typing out their description for those images. And we also asked them to provide descriptions in 2 different contexts. We asked them, describe this image. But we also asked them, hey, this person's gone missing, can you help describe them to help us find them? These 2 different contexts produced different information, and this is crucial to the point of the rest of the analysis here. Overall, 53 users provided information from this. This was all gathered at the NASA cafeteria, so these are all 53 employees of NASA in some form. Each user provided only either verbal or text input. They did not provide both, but they did provide information in both of the different contexts, and they did provide information for all 5 images. So this was done a little bit before I got here. When I joined the AI, this is the data set that I walked into, and this is the data set that I'll be analyzing for the rest of this presentation. Previously here at the AI, we've done some research on modalities of communication, ways in which humans can interact with the machine. We've done lots of information and lots of analysis on speech, gesture, different ways of interacting. What we're specifically looking at with the HINGE data set is what is unique to descriptions provided by these different modalities, and what is unique to descriptions provided by these different contexts. If we can figure out what makes them different, we can determine if one might be preferable in certain situations, in certain contexts. We also wanted to see what characteristics of language correlated to success. If we can figure out what makes a better image, or what makes a better description, we can help to work to elicit better descriptions, which hopefully then leads toward improved success in the mission. So those are the questions that we're trying to answer here. When I joined, I started using a couple of different tools from linguistics, a couple of different communication analysis tools to help us interpret this data. The first one I want to talk about is AntCon, which is a really silly name. It's a concordance analysis software, it's a corpus analysis software by a guy named Lawrence Anthony, so he named it Anthony Concordance or AntCon, that's where it comes from, I'm sorry. But this basically analyzes a corpus of text, a corpus of descriptions, and it helps us see information on general word count, how many words are spoken, how many words are typed, what context, how many words. But it also lets us see things like clusters, n-grams, tokens, how many different types of words. And it gives us some interesting, not great, but interesting visuals to help us this comparison instead of just looking at numbers. This is what it looks like. It's nothing fancy. I also use a tool called LINQ. It stands for Linguistic Inquiry and Word Count, which has been around in the field for a while now, and there's some interesting analysis on using LINQ to help predict more human factors of communication, things like how authentic speech is, where in the hierarchy a user views themselves, really interesting linguistic comparisons like that. And basically all of this is based on 94 data variables, some of which are just simple percent of total. So how many words in the total corpus are pronouns, how many words in the total corpus indicate fear, things like this. But there's also a bunch of really proprietary algorithms that I don't know how they decide, but they tell you things like, what is the clout of this description? What is the emotional tone of this description? So it gives us a lot of different variables to work with. Luke kind of looks like this. It's just a spreadsheet. You don't need to dive back into the back end much. But I took those tools in conjunction with some analyses that Brian created. Brian, who's sitting in the back, did a part of speech analysis over the whole corpus. So I want to talk about some general results right now. The first chart over here is a concordance chart of appearances of the word horse in image 1. What that means is each black line in these bars is one time that the word horse appears in descriptions for one image. The top bar is every time it appeared in the first context, that is the described as image context, and in the text modality, that is people typing it. Second one is context 1, but people who spoke instead of typing. Third one is context 2, that's this person went missing, help describe them so we can find them, in the text modality, and then context 2 in the verbal modality. And what I hope you can see from this, even though that's a lot of explaining that's necessary, what I hope you can see is there are far more black lines than the top two. Those top two are the context ones. So there are more occurrences of the word horse in context 1. Maybe that's interesting. We see something similar over here. This is appearances of the word yellow instead of the word horse. Same explanation as over here. Top two are context 1, bottom two are context 2. So you can see that there's more appearances of the word yellow in context 2. Okay, we can see that, but are we really interested in occurrences of the word yellow and occurrences of the word horse? No, those are image specific, right? Not every image we look at is going to have a horse. Not every image we look at is going to have the color yellow. What this can suggest to us is maybe we're starting to see more nouns in context 1, more nouns like horse. Maybe we're seeing more adjectives in context 2, more adjectives like yellow. So we can start to develop patterns of what type of language is used in these different contexts. Okay. Maybe that's not even as useful as we wanted to as well. We can start to describe the communication and the words that we're seeing using a lot of these different techniques. This one, things are in a little bit different order, but it's basically the same premise as before. This is showing you appearances of the word that. The top two are text instead of context 1. So this is text context 1 and then text context 2. Down here, verbal context 1, verbal context 2. I'm sorry, that's how AntCon decided to display them for this. But what you can see for this is that there's far more occurrences of the word that in verbal context 2. Interesting. We're seeing some words appear more frequently in certain types of scenarios. But that's not useful for us. It's not useful unless we can start to say, we see more occurrences of that in verbal context 2, and verbal context 2 produces better descriptions. That's when it starts to be interesting. Then we can start to say, maybe adding that to your speech or to your text helps to produce a better description for an image. And that brings us to a problem, which is how do we determine what is a better image description? What makes a description good? There's no default metric for this. So again, with the help of Brian, we developed some metrics that we used as stand-ins for this. especially for the context of HINGE, we needed to determine what modality or context produces better descriptions for training a GAN and for producing images from a GAN, right? We also wanted to take a look at, again, not just that training data set, but also after it's been trained, how can we produce better images? What language gets us there? So in order to get to better, in order to get to best, we needed to decide what would be good. So we developed some similarity metrics. We compared the descriptions elicited from the HINGE data set to all the other descriptions within the HINGE data set. The thinking there is that a description that is similar to the rest of the descriptions in the data set is probably going to be better. The more out in left field, is that the phrase? The more out there the description, the less descriptive it's likely to be. So in comparing these descriptions to each other, we developed a similarity which led us to a rank. We were able to rank these descriptions based on similarity. Going forward for the rest of the presentation, if I say a description is good or highly ranked, I mean it is more similar to other descriptions in that context. Not only were we able to do this with the HINGE data set, but we were also able to compare the descriptions to the original Pascal descriptions. Recall that the images used in the HINGE experiment were all drawn from the HINGE 50S data set. Well, the Pascal 50S data set. The Pascal data set included 50 descriptions for each image. We were able to compare our descriptions to the ones already established as belonging to the image in the data set to see if they agreed, to see if they were similar. So that's how we could tell kind of if the descriptions were good going in, if they might make good training data for a GAN. Now we could also feed these descriptions through a GAN and see what images they produced. If a description produces a good image from the GAN, it might be good if we were to use the GAN going forward in a different context. It's roughly the same, based on the algorithm for how the GAN works, it's roughly the same as saying how similar is that description to the set of data used to train that GAN. So a lot of our success metrics come down to these similarity metrics. So when we start looking at the linguistic analysis, the communication analysis, but now correlated to rank, correlated to how good that description is, we have some very preliminary results. Again, there are only roughly 50 participants in this data study, so it's hard to say anything with great certainty here. But we see some basic correlations start to appear. Things like the more text provided, the more words in the description, the better it performed. We also see that the verbal modality, when people gave data by speaking instead of typing, they gave us more text. So we can start to say things like, maybe if we let people speak instead of type, they're going to give us the more information we need to produce a better image. Maybe. Same thing with determiner use. So determiner use we found to strongly negatively correlate to success. This is a very wide definition of the word determiner. Here, our analysis said that a determiner included articles like a and the, but also demonstratives like that and this. We saw a graph of that earlier. We see that the more determiners appear in a description, the worse it tends to be ranked. We also saw that both verbal modality and context one tended to have fewer determiners, suggesting that maybe descriptions elicited via those means might produce better images. So we can return to this chart we saw before of the word that, and we can start to say, okay, we get more instances of determiners down here in verbal context too. Maybe this is the way we need to gather our descriptions in order to produce the best image from the GAN. Maybe. So that's looking at similarity metrics, but we can also try to feed these descriptions into a GAN to see if the image produced is interesting, to see if it's good, to see if the description led to a good image. The problem is we didn't have a GAN built to process human images. Jimmy is working on that as we speak, but when we ran the analysis, we didn't have one. So we had to focus in on this idea of similarity to training data. If our description is similar to the data used to train the GAN, it should produce a better image for the GAN. Since we don't have a HINGE GAN, since we don't have a human GAN, we took a look at analyzing the data used to create the GANs we did have. Specifically, this is the cont'd data. This is descriptions of birds. And we have a GAN that will take a description of a bird and output an image of that bird. So in analyzing the data that we had for these, we saw some different linguistic characteristics than what we saw in the HINGE data set. We found shorter descriptions in the cont'd data set than we did in HINGE. Remember that for HINGE, we thought that the more text you provided, the better the description would be. Here we're kind of seeing that good descriptions are shorter. We also saw the opposite determiner correlation. The more determiners you use, the better the description tended to be. Also higher authenticity scores. Again, this is a proprietary loop algorithm, so I don't know what goes into an authenticity score, but the more authentic the language, the better it tended to, the better image it tended to produce. It's important to know here, however, that the descriptions for the cont'd data set, the descriptions for Pascal even, were elicited in a different way than descriptions for HINGE. We asked for people to provide data in 2 different contexts. For cont'd specifically, they've published out data saying, hey, we tried to get people to just describe an image, and we found the descriptions to not be good, so we did it in a very specific way, in a way that didn't match necessarily what we were doing with HINGE. So these descriptions are designed to be a little different than ours. So because of that, because we're seeing different linguistic features, but we still want to know what goes into making a good image, we dove in a little deeper into the BirdGAN itself, into the cont'd data set that provided the descriptions for the BirdGAN. In analyzing this data, we found that positively correlated with rank were the linguistic features of more nouns, more adjectives, more determiners, more subordinating conjunctions, and a higher word count. Negatively correlated with rank were authenticity scores and number of parts of speech. So with this, it's kind of weird to combine these two. What it's kind of saying is use more words, but limit the words you use to a small number of parts of speech. Don't get all weird and eloquent here. Keep it simple. And we tested this to see if we could produce better images this way. Going forward, I'm going to focus on subordinating conjunctions. In our data set, subordinating conjunctions were, we call them ins. That's the tag that the part of speech tag we used, is in. The predominant subordinating conjunction in our data set is the word with. So if you want to think of that going forward, you can. But this is kind of an example of what using a lot of subordinating conjunctions would look like. We took one of the good descriptions to make all of these images, and we ran it through the GAN 10 times. So each of these images is one good description that used a lot of ins, creating the image, and the description is down here. The bird has a brown back with a spotted brown and white breast, with a yellow stripe on the head, and a short brown beak with long brown legs. And you can see many of these look like birds. Many of these look like real creatures. When we take a good description that has few subordinating conjunctions, we still get many good birds, but we start to see some weirdness appear. When we look at average descriptions that use many subordinating conjunctions, there's some weirdness here too. Some weirdness that is also imitated when we use few subordinating conjunctions. It seems to have less of an effect for average descriptions. But for bad descriptions that use many subordinating conjunctions, we can see some maybe look a little like birds. But when we use few subordinating conjunctions, we end up in a Cthulhu-esque Lovecraftian nightmare world. And this is good. This is what we wanted to see. We identified many subordinating conjunctions as correlating to success in GAN image production. And we see that in the images actually produced in the GAN. This is good. This is what we want to be able to say. It means that these linguistic characteristics we're grabbing are likely good descriptors and predictors for success in using the GAN. But that was with the BirdGAN, right? We want to bring this back into HINGE. We want to use this to create images of humans. We don't just want to use this to create images of birds. So for the future, we're going to try to get more data. That's the primary goal here. 53 users is not enough. Lisa is going to be running an Amazon Mechanical Turk task to get us more data so we can rerun these analyses, make sure that all of the observations we've made are correct, that they work for more data points, and also widen our demographic pool so it's not localized to Hampton, Virginia. We want to be able to use linguistic feature sets to predict context 1 versus context 2. That's going to help Jim E. as he prepares descriptions for his human data sets, and he can create a human GAN. That's awesome. And turns out we do have a feature set that works for that. Our analysis is able to provide that. We also want to be able to use linguistic features to suggest whether a description is good. This is something that Ryan is working on right now. You can enter in a description into his interface, and based on our linguistic analysis, it'll provide you feedback as to whether this is probably a good description that'll produce a good image through the GAN, or whether it needs some help, and here are some ways that you can help it. This is a concrete way in which this linguistic analysis can help to encourage a user to provide better information, to help establish a relationship between the machine and the human, and to produce better results as the outcome. Also, future work from this is we're working on presenting this information out into the public. So far, we've written about 12,000 words of this. We've got an extended abstract at SciTech. We're working on 2 other papers presenting specifically on the linguistic aspects of this, determiner use of personal pronoun use, and the loop tools especially, but also context-dependent interfaces, this phenomenologically inspired, situated work that keeps a broad user base, but limits the usability to a degree that helps improve the functionality of the interface. And we're doing all of that informed by HINGE. So that's predominantly the work that I've been doing for this summer. In addition to that, this is kind of a love letter slide to the collaboration that I've gotten to work with at the AI. A lot of the HINGE stuff has been working really closely with Brian Barrows, with Lisa Levy, with Mary Carolyn last when she was here, and Miranda Smith. But I've also gotten to work closely with Megan Chandradana on writing another abstract for another paper. I got to, the first minute I got to the AI this summer, before I even put my bag down, I got to dive in and start working with Lisa on the paper for aviation, and that's always a lovely feeling to immediately be useful and necessary, and that added collaboration is always a lot of fun. And I got to work with Peyton a little bit on blog posts for the AI blog, so I've been doing a lot of writing, a lot of language analysis this summer, but it's been a lot of fun.